In this section, we take a look at quadratic equations. Quadratic equations are equations that are in the form of ax squared plus bx plus c equals 0, where a doesn't equal 0. Now, if you think about that for a minute, if a equals 0, it would just be bx plus c equals 0, and that would be something that's linear. This is something that's quadratic. You'll recognize them because they'll have a square on the variable. Functions are in the form of f of x equals ax squared plus bx plus c. If you notice, the only difference here is this. The f of x in most equations represents your y value. So we'll see the function notation most of the time in this book. Zeros are solutions to these equations. Now, if you think of quadratic equations as a graph, it's going to be a parabola. And so if you look at a parabola could be drawn so that it crosses your x-axis in two places. So it might have two zeros. These are the solutions where it crosses the x-axis. It could be drawn where it doesn't cross the x-axis, so it would have no solution, or it could be drawn where it only crosses in one spot, so it might have two solutions, one solution or one zero. So this is what a quadratic equation looks like graphically. Your first objective for this lesson is to solve quadratic equations. So you are going to have a couple of ways that you can do this. One way would be to factor if the quadratic equation is factorable. Now, let's just review factoring just a little bit. If something is a quadratic equation, we said that it would be in the form of ax squared plus bx plus c equals 0. You may have to move things around to get it equal to 0. For instance, if I gave you this one, it's not equal to 0, but we can fix that simply by moving the 10 to the other side. And now it's in the form of a quadratic equation. This one is factorable, and all of these quadratic equations, since they are quadratic, will be trinomials. So you can look at it, and if there is a 1 in the front, so in other words, if that variable is single and it doesn't have another number in front of it, 2, 3, whatever, then you can find factors of this last term, the c term, that add up to the middle, and you can factor that way. This one, there are factors of 10 that add up to 7. Factors of 10 that add up to 7 would be a positive 5 and a positive 2. So factoring something like this is simple. You just sit out your two sets of parentheses, you put your factors in them, and you split whatever variable this is. So it's an x squared, so it would split into x and x. Since these are quadratic, this is always going to be even, and you're going to be able to split it. Now, to solve, you just set each factor equal to 0. And you solve. And that's just a quick little review of being able to factor these. You can check it by taking your answers and plugging them in one at a time and just see if they work. You want to be confident that your answers are correct. Now, not everything will have a 1 in the front, so we need to look at one that doesn't. This one does not have a 1 in the front, but we can move this minus 2 over, and it's in the correct format. If we wanted to factor it, since it doesn't have a 1 in the front, what we would do is we would use what's called the AC method. Remember, this is A and this is C in quadratic form. So 5 times minus 2 is minus 10, and we find factors of minus 10 that add up to the middle term. So factors of minus 10 that add up to positive 3 would be a positive 5 and a minus 2. And you take those two factors and you write them in place of the number that they add up to. So we would write 5m squared plus 5m minus 2m and then minus 2. And we now have 4 terms. And what you do when you have 4 terms in factoring is you do grouping. So you group one set of terms and another set of terms, and you pull out the common factor. So in this first set, the common factor is a 5m. And when I pull out a 5m, I have an m left and a 1 left. You always pull down this sign, pull out the common term out of this one, which would be a 2. So negative 2 goes into negative 2. I have an m left. Negative 2 into negative 2 goes positive 1 times. So now the m plus 1 is my common factor, so I can pull it out. And I have left here a 5m, and I have left here a minus 2. So this is how we would factor something that doesn't have a 1 in the front. And then the rest of it's the same. We just set it equal to 0, and we solve. And we can always check these, and you should always check your work to make sure you're right. So that one has 2 answers to it. Now let's take a look at this one. At first glance, it looks like it is factorable. So I have factors of 7, and I need to find factors of positive 7 that add up to 6. Well, the factors of positive 7 are 7 and 1, or negative 7 and negative 1. Neither of those add up to 6, so this one cannot be factored. When something can't be factored, or if you're just not good at factoring, you would want to use the quadratic formula. The quadratic formula is spelled out in your book on page 249, and this is your quadratic formula. X equals minus b plus or minus, that means there's going to be 2 answers to this, the square root of b squared minus 4ac all over 2a. So this is your formula, and remember that quadratic equations are in the format of ax squared plus bx plus c, so the number in front of x squared is a, the number in front of x is b, and the number that's over here is your c, and you simply plug those numbers into the equation and you're going to get 2 answers. So we would do x equals minus 6 plus and minus 6 squared is 36 minus 4 times 1 times 7, all of that over 2 times 1, which is 2. You want to be careful inside here. If, when you do the math inside there, you have a positive number, you're going to get 2 positive real answers. If, or they could be negative, but you're going to get real answers. If the number inside that is a 0, you're only going to get 1 answer. And if the number inside there is negative, you're going to get 2 imaginary answers. So when we do our math in here, we have 36 minus 28, and 36 minus 28 is 8. So this is what we have now. Now, there are 2 ways that you can look at this, and if you're in this class, that means that you are probably on your way to calculus. So you need to make sure that you can get accurate, exact answers. Probably in the past, you've been getting approximate answers where you would take your calculator and do the square root of 8, and then you could do minus 6 plus the square root of 8 and minus 6 minus the square root of 8, and you'd have 2 decimals. But we're going to focus on exact answers because you're on your way to calculus. So what you do is you take the number that's underneath the square root and you try to factor it. So if I look at 8, 8 is 2 times 4. 2 can't be factored, and 4 is 2 times 2. So I have these prime factors. Since this is square root, there's really an imaginary 2 out here. So what you're looking for is 2 of the same number. Since I have 2 2's, 1, 2, because that's a 4 and the square root of 4 is 2, can come out of the radical. So it now looks like this. So that 2 got to come out. This 2 doesn't have anything to pair with it, so it must stay inside. Anything that's left that doesn't have a pair with it will get multiplied together, and that's what will go inside the radical. So now your answer looks like this. As long as you have 3 things here in this triangular shape that have something in common, it can be reduced. So 2 will go into all 3 of those numbers. Now, not the radical. We don't worry about the radical here because it's not really a 2. It's a part of a number. So you look at the 3 numbers, and if there's something in common, it can be reduced. So my final answer for this one would be minus 3 plus or minus the square root of 2. Now, we want to look at a couple of special cases with this too. So let's take a look. Let me do another slide here. You had inside your radical, let's say you had something that looked like this. Let's say you got finished and you ended up with something like that. Anything that is a negative underneath the square root of a negative 1 actually has a definition, and its definition is I, and that stands for imaginary. So you would still take the 45 and you would try to factor it. And so I have 2 3's, so a 3 would come out. But an I would also come out because it's imaginary. So that 3 would get to come out. The 5 would stay in there. These 3's have something in common, which is the 3. So I can reduce by 3. So my final answer to this one is negative 1 plus or minus I square root of 5. In your book, you're probably going to see the I written in the back, but it's better to write it in the front so that you make sure that everyone understands that the I is not underneath the radical. So those are things that can happen when you're looking at your quadratic formula. You need to make sure that you practice. There'll also be a video that you will have that will talk about analyzing some of these. So make sure that you do a little bit of the practice and that you understand what's going on with these.